Hey guys, Mr. Gran with the Quarter B Final Review IHD edition, this time for Chapter 8, the first part of Chapter 8, Rational Functions. So our Chapter 8 Part 1, what we did was factoring. This could include sum and product, voodoo, difference of squares, also simplifying rational expressions, multiplying, dividing rational expressions, adding, subtracting, and then graphs. And I think we're going to keep solving rational equations off of this one to make it a little bit simpler, so you don't have to worry about those. So just a quick example of kind of all of those topics. So as far as factoring goes, sum and product to review real quick. This is where you're looking for the sum to equal 3 and the product to equal 2. So two numbers that multiply to 2 but add up to 3 are 2 and 1. And so the factored form of this would be x plus 2, x plus 1. And remember, you're like unfoiling it. If we went through and foiled this back out and combined our like terms, we would get back to this. The voodoo method factoring. Now this one's a little more complicated because of the 2 that's in front. So if we start by multiplying the 2 over here to the 4, that's going to give us x squared plus 7x minus 8. Now we can approach this like sum and product factoring. So two numbers that multiply to a negative 8 but add up to a 7 are going to be positive 8 and negative 1. And now the trick to this is at the end here, we have to take that 2 that we multiplied by our constant to start with, and we sort of have to undo that by dividing our constants by 2. So divide those by 2. Let's see, x plus 8 over 2 simplifies to plus 4, but 1/2 does not simplify, so we'll take that 2 and we'll move it in front of the x and make a 2x minus 1. All right, and then the last one, difference of squares. Anytime it's x squared minus a number, we should be thinking difference of squares, especially if this happens to be a perfect square like 64. It is always going to be x plus the square root of the number, which in this case is 8, and x minus the square root of the number. All right, let's see, as far as simplifying goes and some of our basic operations. So simplifying, you may get the factored form of something. You may also have to actually like factor it out to simplify it. But ultimately you would get something like this, where in its factored form you've got some stuff that matches on the top and the bottom. And when that happens in a fraction, of course that cancels out. And so we would just cancel those out, and we would say that that would be equal to just x minus 2 over x minus 4. Then as far as multiplying goes, now multiplying with these is fairly simple. We can really treat this as one big fraction if it's multiplying. Now again, you might have to factor this, but for the purposes of this video, to keep it short, I'm giving you pre-factored ones. So now we make it one big fraction. Now I'm just looking for what matches on the bottom and what matches on the top. And I can cancel those things out, and this will equal 1 times x minus 2 on top is x minus 2 over x plus 3 is left on the bottom. Now, as far as dividing goes, it's just like multiplying, but there's one extra step, and that step is keep, change, flip, meaning we are going to keep the first part, the x plus 2 over x minus 3 in this case. We are going to change this to multiplying, and then we're going to flip the second part to x minus 4 over x plus 2. Now that it's multiplying, I can treat this like one big fraction and cancel out what cancels on the top, what matches on the top and the bottom will cancel out, and what I am left with is, in this case, x minus 4 over x minus 3. All right, adding and subtracting. Now there's really two versions of this. One is going to be when the denominators already match. That's the easier one, because then all I have to do is either add or subtract them, right? Now the minus right? That's going to go to both things on top. And this is going to be x squared plus 1 minus x minus 4, because that minus changed the sign of everything on top here, all over x minus 2. And then to finish this, we would just combine like terms on the top, and it would be x squared minus x, and then the 1 minus 4 would make a minus 3, all over x minus 2. Then the second part would be if the denominators don't match, you have to make them match. And so in this case, we've got everything factored out. We're trying to add these two. I notice that I've got a matching factor on both sides, this x plus 3, but I've also got this extra factor here, x plus 2. So this denominator needs that x plus 2 if I'm going to add them together. So what I need to do is multiply it by x plus 2. Now in order to do this and make this work, I have to also multiply it on the top so that it doesn't like change the value of it. And what I'm left with then is x plus 2 plus x minus 4, so I can sort of distribute the 1 in, and that just makes it x plus 2, and then add the x minus 4, and this is going to be all over our denominator, our common denominator, x plus 3 times x plus 2. And then I can finish this by just combining like terms, right? The x and the x add together to make 2x. The 2 minus 4 makes a minus 2, all over x plus 3, x plus 2. All right, then as far as graphs go, we're just going to have to identify stuff. So if you're looking at a rational equation, a rational function, and it's in its factored form, the different elements of the graph come from that factored form. Whatever the factor is, if it's only on top and not on bottom, it gives you a 0. If it's only on bottom but not on top, it gives you a vertical asymptote. And if it's on both top and bottom, that creates a hole in the graph. So there's 3 options there. It's either on top, on bottom, or both. It can't be both a 0 and a hole, both a vertical asymptote and a hole at the same time. That's not how these work. Then as far as horizontal asymptotes go, you definitely want to have these rules down. Horizontal asymptotes work by degree, meaning like the highest exponent in the polynomial that would be on the numerator and the denominator. So if the degree on the top is higher than the degree on the bottom, then there's no horizontal asymptote. And that would look something like this, where it would be like x squared on top and then only x on the bottom. Or maybe it's x cubed on top and x squared at the bottom. But the important thing is the exponent is bigger here than it is here. Then if it's the opposite, if it's the lower degree on top and the higher degree on the bottom, it's always going to be y equals 0. And so that might look like this, where it's x plus whatever over x squared plus whatever, where the exponent on the bottom is bigger than the exponent on the top. All right, and then our last scenario is if it is the same degree on the top as it is on the bottom. And this can create a horizontal asymptote that is equal to the leading coefficient over the leading coefficient. And so for our example here, 2x squared plus whatever over 3x squared plus whatever, the exponents match, so the leading coefficient of the top is 2, the leading coefficient of the bottom is 3, so in that case, the horizontal asymptote would be at the line y equals 2 over 3. All right, and that is everything for Chapter 8. Let your teachers know if you have any questions.